And sadly, all of us couldn't be here today. We have Joshua, Mateo, and Remy who also did this for us.
So let's get started with explaining what hydroponic systems are. So the cultivation of plants in nutrient-rich water with or without mechanical support, such as gravel or perlite. It allows us to garden without soil, and it allows us to control the nutrients and also use the maximum amount of space we have. So basically really good efficiency with hydroponics. And the market value for the hydroponic systems range from about $25 to $500, so it's a pretty big range. It's a very expensive industry. Let's get on to what rock wool is. We use this in our hydroponic system with starting our seeds and as well as holding the plants. We use it because it has really good oxygen retention, and it also provides the plant with moisture without rotting the roots. So it's a good balance between both, and it's mold resistant as well. So our objective, the goal of our team is to design a hydroponic system that is not only efficient but also space effective. So when we started our project, we wanted to implement more green spaces into things such as kitchens or offices or even like your house. So we wanted to grow more plants in a smaller area and something that could fit in your residence, basically. About the plants, our plants, they're pretty needy. It takes a lot to take care of them. The nutrients we use are nitrogen, phosphorus, and potassium, NPK, and they're added to the water and they help the plant through each stage of their life. You use nitrogen more towards when you start the seeds. It's for the foliage, makes the chlorophyll and stuff like that. And you use phosphorus and potassium in the flowering and fruiting stage of the plants. We also monitor the pH levels of the water in our hydroponic system, and we usually keep it between 6.5 and 7. We regularly check the plants, the water, the pH with this machine, this little handheld device here. The light requirements, most of our plants require about 12 to 16 hours of light each day. We have a timer on our hydroponic system that tracks that specifically just for that. Our pest control, we did run into a lot of pests issues with our hydroponic system. So we found the best way to limit the pests is just a simple mixture of water, dish soap, and vinegar. And we spray it routinely whenever we see any pests pop up, and that takes care of them pretty well. And these are some of the plants we grew. Tomatoes, peppers, tatsoi, lettuce, and cilantro. Our goal was to kind of like make a salsa mix. So we chose these plants specifically for that. And this is of them in our hydroponic systems. And we transplanted them in the top right.
So our step-by-step plan is first design. We had to make sure we have good measurements, and we did 3D modeling. Our second step is getting materials. We used a PETG filament for our 3D printer. PETG is a type of filament, the material you use in a 3D printer to make our main components of our tower. Step 3 is assembly, where once our parts were printed, we got all the other materials delivered, we assembled our tower. Step 4 is our pump setup. We had to do a lot of calculations to find the right pump and tubing as well. And then step 5, rock wool holders to keep our rock wool straight and make sure they have good root connections. And then step 6 is testing. Here's our tower specifications. Our height is about 3 feet. Our maximum flow for the pump is about 55 gallons per hour. Our maximum for our bucket water reservoir is 5 gallons of water. The minimum we need to keep our pump going is 1 gallon. And the maximum number of plants is 36, but we can increase the height of the tower to increase the amount of plants we have. For our first sketch, we had some challenges. So as you can see on the left, we have our printed, but it took 2 days print time, which can easily lead to failure due to a longer print time. Something as simple as the printer just turning off can ruin the whole print. And then the slide continues from the bottom, which is a reason the printer took more time. And we needed to use more filament to compensate for the supports, as you can see from the line bit on the bottom. And it was also 6 inches in height, but our printer didn't meet that size requirement, so we have to make it smaller. Then for our rock wool holder, it lacked support to keep the rock wool straight, but it fit the rock wool. For our final one, it is now an 18-hour print time. We have a 3-inch height, which now makes it to fit into our printer, much easier printing. And then the slide starts at the top to waste less filament. For our rock wool holder, we have a cage area, which allows for root growth and extra airway, and the rock wool has much more stability. For our 3D printing process, we used the Ultimaker 3, and depending on the room, you had to change the settings of the printer for its temperature, humidity, printing speed, and offset adjustments. A lot of trial and error was made, but we led to successful prints. During this trial and error, we also had to change some of our 3D modeling in between it as well to fix the flaws when it came to printing. And then we turned our sketch into a reality, which is really good.
Yeah, so as we can see, the tower is really, really small. Like I said, this is going to be perfect to implement into your household. It's perfect for herbs. Even if you have it near the kitchen, you can have a fresh supply of herbs always, year-round. Our hydroponic tower was created to store as many plants as possible in the smallest amount of space. For the creativity, we allow the plants to... We uploaded our 3D printing code onto the internet so that anyone could get access to these designs from their house. And for future plans, we also make it fully customizable, so color, really anything. It's meant for your household. So we get questions like how much filament, how to connect each part, will it print well on the printer, and is it user-friendly? It's very user-friendly, very, very simple to put together. You just stack them up, and we have the little locking implements, as you can see here. Those lock in and stack, and yeah. So our future works. We want to build a system for a windowsill, so even more space efficient. We want to take advantage of horizontal space, a system using a double tower, so 2 towers on 1 water reservoir. We want to extend the sidewalls and lowering the speed of the water flow, just in case. We don't want someone like knocking into it and that would cause a spill, so lowering the speed would help manage that. And so we have some acknowledgements. We owe special thanks to Professor Ebert and the Innovation Center. Without them, this project really wouldn't have gotten finished on time because of the 3D printing times being so extensive and long. They allowed us to use their 3D printers for the entire internship. So we're really grateful to them. Our
mentor, Professor
Yeah.
Balza, he gave us a lot of tips and tricks and gave us a lot of guidance throughout this whole project. And we'd like to thank New Jersey Pathways who funded this internship, and also Dr. Mohammed, our supervisor. Thank you. Any questions?
About the lighting, where is the best position? Because to put this instrument, what is the lighting that you need to in order for the plants to grow?
You can leave it near a window so it can be able to get the light it needs. But we're also planning to try and make a light system that can connect to the tower, so people don't have to worry about leaving it near a window or leaving it on their patio.
So there was a second engineering team whose specific goals were to just implement additions to our hydroponic tower. So they built the cap of the very top of our hydroponic tower, and they also built special lighting system that kind of like wraps around the system, like kind of like Christmas tree lights, I guess. Yeah. So that would be implemented on top of our system. Any other questions?
You mentioned a certain volume of water that you designed around, so do you have to add water? How much, how often, how do you know how much to add? And do you have any concerns about quality of the water in terms of like the mineral content and that kind of thing?
So with our system, on the basin, there's going to be a fill level. So like a fill level with, I don't know, like baking, or when you add the water to a ramen cup, there's a fill level. So you'll always know how much water to put in the tank, and you just have to top it off whenever you see that the water is low. And not only that, there are sensors that are implemented that tell you when the water is low. And the only thing you really have to not really monitor, because we also have sensors for, is the pH. We have sensors that monitor the pH for you, and you'll see that with his presentation. His is also implemented into our system. Any other questions?
One of your goals is the low cost.
Yes.
So how is the low cost evaluated for the lifetime of the project from plantation to harvest?
So we measured that by comparing it to other hydroponic systems that have the same technology but cost way more. So we really wanted to implement kind of like a middleman. It's not going to be as cheaply made as, say, like the $25 hydroponic system, but it's not going to be as expensive and more intensive as like the $5,000 hydroponic system. It's something in the middle. So we wanted the small system with the implementation of the basic just monitoring technology. So that's how we measured the cost. It's going to be a medium.
We wanted quality over quantity, but people can also add to their tower as they see fit for additional.
Oh yeah, it's fully customizable. You can put as many levels as you want to it, and that's really what our design was. It's really up to the user how they want to use it. You can keep adding more horizontal, lateral levels to it or not. It's really up to the user.
So is this hydro tower for growing plants, transplanting, or like whole life cycle?
The whole life cycle. So if you, like I brought up before, you can have this in your kitchen, just having a constant supply of herbs. You can start them in there and you can leave them in there their whole entire life, basically. And you can switch them out whenever you want.
Do you have a formula for the proportions of chemicals that you mix into the water that would best suit the plants that you grew, or would you make recommendations for different combinations, different proportions of those chemicals for other kinds of plants? Would you make recommendations in the types of plants that the customer would want to grow?
Yes, so it depends on the plant. Let's say we're doing tomato, it will require a lower pH. It's around 6 to 6.5, but let's say you're doing something like herbs, it's about 6.5 to 7. And can you repeat the rest of your question?
Well, just that if you were to provide this as a product, would you include with it recommendations for proportions of those additives to the water for certain groups of plants?
We could, absolutely, yeah. But the measurement of the nutrients is based on the amount of gallons in the reservoir. So that's the formula we use. I think it would be pretty effective if it's up to the user to decide based on what other plants they want to grow to adjust the nutrition level. But we give you a base equation for the nutrients just from the amount of water you put in, which is pretty consistent for all plants. It's like an all-around equation for that.
Thank you.
You're welcome. Any others? Well, that concludes our presentation. Thank you guys so much for listening. I'm super grateful to be here, and I loved being in this project all summer. I worked very hard for a lot of this, and also Alana.
Thank you so much for having us here, and we're so thankful to be part of this project and meet all these wonderful